right, here we are with some real-world problems for ratios. These are solutions to Chapter 4, Lesson 3, Day 3 homework. So you do have some extra practice problems. You know the drill. All right, so for these problems, I do recommend taking some time to just sit with the information, process through it, because with these questions, you might not know exactly how to finish the problem, meaning how to do the final solving, but you do have enough information and knowledge to at least get started with the questions. So start somewhere, see what you can see, and then work through the problem with what you got. So Harlow, the ratio of Harlow's savings to Finn's savings is 3 to 5. So Harlow is purple, Finn is blue. The ratio of Finn's savings to Jake's savings is 3 to 2. The difference between Finn and Jake's savings is $65. So the names and numbers in this are just an example, and there's no reflection on no judgment on any humans at all. So we need to calculate the amount of Harlow's savings. So I'm going to start out because I don't exactly know what my first step to solving is going to be, but I do know that I can at least take this problem and show it somehow. So we have Harlow is 3 to 5 to Finn. 1, 2, 3. Finn's is going to be 5. And let me quick grab some colors for them. So we know Harlow's, and then Finn's. So now we need here, noticing that Jake's savings, Finn to Jake ratio is 3 to 2. So what that tells me is that this amount of money that Finn has here has to equal, those 5 groups have to equal the same value as 3 groups when we compare them to Jake's. And so I know I'm going to have to do some equivalent ratio work to figure this out. So I'm going to set this up our other style vertically. So we have Harlow, Finn, and then Jake, because this allows me to see the overlap a little bit better and then know what equivalent ratios I need to use. So again, we have Harlow to Finn is 3 to 5, Finn to Jake is 3 to 2. So looking at this Finn ratio here, those values need to be the same, and so it looks like I'm going to have to use equivalent ratios for both of these two ratio sets. So I'm thinking to myself, all right, if we have a 3 to 5 and we have a 3 to 2, what could be a common number that 3 and 5 are both factors of? So that way we can use that term in common. And I know that number is 15 because 5 times 3 is 15. So now I need to think about this 3 to 2 ratio and try to find out what is my missing term. If I know this 3 becomes a 15, that's times 5. So in order for this 2 to be proportional and have this ratio be equivalent, I would also need to multiply that by 5. So this ratio of Finn to Jake being 3 to 2 is equivalent to a 15 to 10 ratio. Now that step is really helpful because now I can look at the Harlow to Finn ratio, and I know that 5 times 3 is 15. And so here, when I'm looking at this 3 to 5 ratio, I need to figure out what do I have to do to this 3 to make a 3 to 5 ratio equivalent to a something to 15. Because that was times 3, I also need to do that times 3. And so now I have a 9 to 15 ratio. And so because Finn's value here is 15 units, 9 to 15 and 15 to 10, I can combine into one ratio of 9 to 15 to 10. We have that overlapping term with Finn that allows us to combine those two, and now we can compare across all 3 terms in this ratio pretty easily. So I am going to quick update my drawing now based on this information. So it looks like for the Harlow to Finn, what I have here already shown is this portion, or I guess it's easier to see it right there. So I need to take each one of these groups and chop them into 3. So that way now Harlow does show 9. So she had 3, it became 9. I wonder, I'm going to try using a different color. That way this is a little bit, we can see the difference here. So we had Harlow's 3 became 9 because they're equivalent. And then Finn's 5 are going to become 15. And that checks out. 1, 2, 3, 6, 9, 12. So we do have 15. I'm going to get rid of that So now when we compare the Finn to Jake ratio, we know that that is 15 to 10. And those are 15 of the small units. So I'm going to borrow this bit here because I know I'm going to be using the same size ratios for Jake's. Get rid of that. So if I only have this amount here, that's 4 groups of 3, which is 12. So that's too many. So I'm going to get rid of this. And that right there looks like it is now going to be, those are 10 groups of the small unit bars. Right? Yes. Okay. So that does seem to show. We have Harlow with 9 portions, Finn with 15, and Jake with 10. Shows our 9 to 15 relationship. So here I've already leveraged a lot of my knowledge about ratios, but I haven't actually started calculating and turning this into dollar amounts. And that is going to be using this final piece of information, that the difference between Finn and Jake's savings is $65. So on this bar model, we have an extra number of groups right there. And the value of that set of groups is $65. So we can tell that the difference between Finn and Jake's ratio, that 15 to 10, is a difference of 5 units. Finn has 5 more units than Jake does. And the value of those 5 units is $65. So that means if I do 65 divided by 5, that's going to tell me the value of 1 unit. So 65 divided by 5 is like a 50 and a 15. 50 divided by 5 is 10. 15 divided by 5 is 3. So 1 unit must equal $13. So we've now figured out that every single one of these tiny little boxes, here, every single one on that whole chart is $15 each. And Harlow, up here, she has 9 units of $13. Apologies, that's supposed to be a 13. Harlow has 9 units of $13. So to calculate Harlow's value, I'm running out of space and my work is getting messy. But you know what? The beauty of Notability is that I am able to shrink things down to give myself some more space to work with. I'm going to take this work, move it out of the way. So now we can continue working with Harlow's information here. That 9 units of $13 is the same as 9 times 13, or 90 plus 27, which is 117. So Harlow has $117 in her savings. Okay. That was a lot of work just to calculate that one piece of information. I think I would have just called Harlow and said, yo, how much do you have in savings? Although I can't imagine a situation where I would need to know that information. Regardless, let's move on to something a little bit more tasty. So the ratio of the number of blueberry muffins, obviously that would be blue, to chocolate muffins, well, I guess we'll make that green, in a confectionery or a bakery was 3 to 2. After 144 blueberry muffins were sold. Oh, so that sounds like a change in our total. The ratio of the number of blueberry to chocolate muffins changed to 3 to 5. Okay, so this one, we have 2 quantities. Our total is going to be changing, getting smaller, and that's going to affect our ratio. So let's start out and at least get our initial ratio on the page so we can check that out. So we have blueberry to chocolate is 3 to 2. So even if I don't know exactly what calculation I need to do to get started, I can always start with showing that ratio. And I think that's a really important step. At least get some momentum mathematically going so that way you can get working. All right. So I like to think of these with a quick little picture and then some before and after ratios. So before, we had blueberry to chocolate. Ooh, that's a 3. Blueberry to chocolate was 3 to 2. After, that ratio of blueberry to chocolate was 3 to 5. Now, in this situation, asking yourself the question of what has changed and then what has stayed the same. what value those are going to be really important questions because in here, the only type of muffin that was sold was blueberry. So the only one that was changed is going to be this amount here. Even though if you look at that, those terms, 3 and 3, they are the same. So that must mean that the value of each of those units had to have changed. And we can see that as well with our chocolate muffins because no chocolate muffins were changed, but this 2 is now a 5. We have 5 units, or a ratio of 5. So that tells me that we're going to have to do some manipulating here because if that 2 units and those 5 units are the same value, then we're going to have to do some equivalent ratios. Now, 2 doesn't multiply nicely into 5, but I know 2 and 5 are both factors of 10. And so I'm going to turn my chocolates into a ratio where the value of the chocolate term is 10. And so for me to make this into a 10, I have to multiply that by 5. And so I'm also going to have to do that same thing to the blueberries. So now I have my blueberry to chocolate ratio at the before is a 15 to 10. So I'm going to quick show that on our bar model. Okay. So now I've chopped each one of those into our units. We have 15 blueberry to 10 chocolate. Now in the after, let's get this chocolate term into a 10 as well, so that way we can compare how did the units of blueberries change in this scenario. So to turn that 5 into a 10 using equivalent ratios and proportional relationships, we have to multiply by 2. So now we have a 6 to 10. So I'm going to write these over here. We started with a 15 to 10 ratio, sold some of the blueberries, and now we ended with a 6 to 10. So when I compare those, because my total is changing and it's decreasing, I know that we sold 9 units of blueberries. So this 144 blueberries that were sold, blueberry muffins, was the same as 9 units because that was the amount that changed. Our chocolate chip stayed the same, but our blueberry changed by a value of 9 units. So that means up here, let's see, we did red. That means this blueberry, if we had 15, that's only going to leave us with 4. So we sold these 9 units, or those 144 muffins. All right, so if we do that, we can calculate the value of 1 unit by doing 144 divided by 9. And 144, you could set this up long division, or I'm going to think of this like a 90 and a 54, because 90 divided by 9 is 10, 54 divided by 9 is 6, so that is 16. So 1 unit is the same as 16 muffins. Now this is a wild problem because we're still not done yet. We've done all that calculation and we have not finished. The question is asking how many more blueberry muffins were there than chocolate muffins. So we have to go back to our original, because this is at first, let's go back to our original expression of 15 and 10 to calculate the number of blueberries and the number of chocolates. Blueberries was 15 units of 16, and chocolate was 10 units of 16. So 10 units of 16 is 160. 15 units of 16, well, let's see. I know I'm just going to solve this like it's 16 times 5 and 16 times 10, because that's 160. And 16 times 5 is going to be half as much as that, so that's 80. Add these together, we get 240. Okay, so we have 240 blueberry, 160 chocolate chip, and to figure out how many more of that, we're just going to do some subtraction of 240 minus 160, and you would get 80. Now, that seems like I probably could have also just calculated the difference between there were 15 units of blueberries and 10 units of chocolate. So we know the difference is 5 units. 5 times 16 is 80. So I guess we could have done that. So our answer is, at first, there were 80 more blueberries than chocolate chip muffins. That is a ton of math in one small problem. All right. Hopefully this one's a little bit more straightforward. We have one piece of ribbon that is cut into 3 strips in a ratio of 2 to 1 to 4. So it doesn't tell us what those are, but I'm going to just, come back. I'm going to call that A, B, and C. So part A, B, and C is 2 to 1 to 4. Okay, and we know that this total ribbon, if we put them all together, was 56 inches. And we want to know the length of the longest piece, which in this case is going to be piece C. So in our bar model here, we have 56 total inches, and if I add these up, 2 plus 1 plus 4, that equals 7 units in the whole bar. So 56 divided by 7 is 8. So 1 unit equals 8 inches. C equals 4 units, or is the same as, 4 units. So C is the same as 4 times 8, which is 32 inches. So the longest piece is 32 inches. So how much longer is the longest piece than the shortest piece? So this is the difference between C and B. Well, if C is 32 inches, B is only 1 unit, so that must mean that it's 8 inches. So to find that difference, we will do 32 minus 8, and we get 24 inches. So the difference is 24 inches. Much more straightforward than question number 2, or question number 1 even, but I feel like they're both reasonable if you take your time and see, if I know this, what can I figure out? How is all of this related? So, awesome math.